Hey guys, it's IDW and today we're going to talk about objects and subroutines. This is the first electrical engineering video that I have ever done 100% scripted, so hopefully this will go well. So to start off, what is a subroutine? All a computer really does is solve problems. And along the way, you might have individual functions that solve simpler problems in order to solve a bigger problem. A certain problem, such as multiplication, may have to be solved more than once during a program. For example, you might need to multiply two numbers by each other more than once during a program. To maximize efficiency, one might take the code to solve that problem and separate it from the rest of the code. When you need to do it, branch to the start of that code, and when it finishes, branch to where it started. In this case, the code that you are branching to is called a subroutine. Subroutines are one of the most fundamental things that a computer can do. When a computer solves a problem with a subroutine and then jumps back to the code, it is effectively treating the subroutine like an instruction. So you can treat subroutines as functions that are not already programmed into the computer. For example, if your computer didn't have a multiplier and you needed to multiply, you could jump to a subroutine that does multiplication and treat that subroutine like it was an instruction in your computer. When you jump, or enter into, a subroutine, it is important that you store all of the information currently in your registers somewhere that you can easily access them. This is to ensure that the information in the registers will be replaced as soon as the subroutine finishes. But then we would need a place to store the information from the registers that we can access at any time. The most practical place to store this information is in a stack. When you jump to the subroutine, push all of the information from your registers onto the stack. And then when you end the subroutine, you can pop all of the information off. A stack is used instead of a queue because if you jump to a subroutine within a subroutine, the variables will be at the right point in the stack. Think about it. It's very important to note here that when you push the information in your registers onto the stack, all of the information in those registers will be temporarily lost. You should make sure, therefore, that all the information in your registers is a pointer and not data. This is a major reason not to store data in registers, and the main reason why I've been suggesting that you avoid doing so. Similarly to hardwired functions, subroutines require operands or arguments to work. When you jump to a subroutine, you have to make sure that the pointers pointing to the arguments for that subroutine are sent into the registers. You want to use pointers for the reasons that we just discussed. And now on to objects. Objects are basically virtual things. Everything that you use on a computer that isn't physically there, like the window you're watching this video on or the video itself, is an object. Objects are made by splitting memory up into sections one by one. Each new section contains all information related to that object, such as the size of the window and the length of the video. Now a quick bit of terminology for today. The technical word for creating a new object is to declare a new object. It's important that you have some way of keeping track where each object starts and ends. If you don't, then when you declare a new object, you won't know where to split the memory at. And that's about it. Next time we're going to be talking about object-oriented programming. I hope you guys have enjoyed, and I'll see you guys next time.